Good morning, students. Now, today our topic is the types of physical quantity. As we know, in the beginning of the chapter, we had learned about the types of physical quantity, and they are the fundamental and derived quantity. But here we are going to discuss on the types of quantity, but on the basis of their dimensional formula. See, in physics there are four physical quantities we can take in the terms of dimensional formula. The first one is known as dimensional quantity, right? The dimensional quantity, it can be two types. It can be variable and it can be constant. So I can write here the A, this comes under this dimensional quantity, dimensional variable quantity, right? And other is the, it's called the B, dimensional constant quantity. Actually, we have to write it as the constant. Point number two, dimensionless, dimensionless physical quantity. So it can be also two types. A, dimensionless variable quantity. Another is the dimensionless constant. C. So here we have written the types of physical quantity in the terms of dimensions. Some quantity has the dimensions, but the quantity can be variable and can be constant. For example, the dimension variable quantity is the length, meter, area, speed, acceleration, force. So these all are the quantity and which can be changed with time. But they have some dimensions. That's why we have written the dimensional variable quantity. So just note down the examples, the force, the speed, acceleration, velocity, and the work, these all things. And the point number B is dimensional constant, a physical quantity which doesn't change with time. That means its magnitude, its value always remains same, but it has the dimension. We are talking about the universal gravitational constant, and it is denoted by the G. We know about what is the G. It comes from the Newton's law of gravitation, where the G is a proportional constant. It's called the universal gravitational constant, and its value does not change, but it has the dimensions. So that's why this constant comes in this category which have dimensional, right? Now the next point is the dimensionless quantity. The dimensionless quantity, that means some physical quantity they don't possess their dimensional formula, right? And as well as they don't have the unit. But except one thing, there are two or three variable are there. They don't have their dimension, but they have unit, right? So I am writing here dimensionless variable quantity. That means there are some physical quantity are there which changes with time, but they don't have their dimensions, like the angle. The angle formula is arc upon radius, as I am writing the example of this angle. The formula of the angle is arc upon radius. So you can say the arc always measured in the meter, either in a centimeter, and similarly the radius always measured in the meter in the centimeter. Okay. So if you are taking the SI unit is the meter. So if you are writing the 5 meter is the arc and the 3 meter is the radius, so the meter will cancel and only the number 3 by 2 after dividing 1.5 comes, right? So you have seen angle has no unit, but in the SI unit in the SI system, the unit of the angle is the radian, but the radian we cannot convert it into the dimensions. So note it down. As I told you earlier, the angle can vary with time, but it has no dimension. So that's why dimensionless variable quantity, an example is the angle. Many more quantities are there as the relative density. So relative density, you can see the formula in the book in the dimensions formulas list. There is written the relative density. It is the ratio of density of the one substance divided by density of other substance. So the densities, the dimensions and the unit are same. So they cancels and only the numeric values come. Okay. So this is called the dimensionless variable quantity. And this is called the dimensionless constant. Dimensionless constant, that means they don't change their magnitude, that means their value does not change with time, as well as they don't have the unit, they don't have any dimensions. For example, all numbers does not change. 1 cannot change, the 2 cannot change. The value of an electron, the charge value of one electron is 1.6 into 10 to the power minus 19. It does not change. If you are telling that is a coulomb, I am not telling, I am telling only the values. The value of the pi does not change. That's why the pi is known as the dimensionless constant. Okay, so just note it down and you can take them example from the table which is given in the books. Right? Note it down first. Okay. Now I'm going to the next erasing. And our next part is application of dimensional formula. One more thing which I forgot to tell you, that in the book you will find definitely there are some physical quantity, they have same dimensional equations, they have same dimensional formulae. So you can prepare one list of that this type of physical quantity, as well as you will find there are some physical quantity they don't have their dimensions, that's called the dimensionless quantity. So you have to make two separate table for dimensional same quantities and the dimensionless quantity, right? Okay. Now, so the next topic is the application. You can note it down simultaneously. Application of dimensional formula. I am writing. So in this chapter, the application of the dimensional formula are four types. The first one is the to check the validity of any equation, right? So the first one is to check the validity of any equation, which is which we are using in physics as well as in chemistry, as well as in any field of the science. Okay, for example, I am giving the example of it. Okay, so we are taking the first example, the v is equal to u plus at, where the v is known as the final velocity, the u is known as the initial velocity, and a is called the acceleration, and the t is known as the time. How you can say this equation is the valid? So we can prove it by applying the dimensionals concept here. What we have to do? To check the validity of this equation, convert the left side and the right side variables in their respective dimensionals formula. As I know, this is called the velocity. So the dimensional formula of the velocity is LT inverse. So maybe you will say, sir, if you knows, that's why you have written that, how we can. So you can do the practice earlier, then you can come and do this practicing. And the u is also known as the initial velocity. So the dimensional formula of this velocity always the same. Okay. The plus, this is called the acceleration. The acceleration has dimension formula LT inverse 2, and this t has dimensions called the t, right? So this is called the LT inverse. So I am writing as here. This is called the LT inverse. You can do one thing. You can write this because t to the power 1, if we multiply it with the t inverse 2, so the t inverse will left. Okay, so you can see this is called the 1 LT inverse and other LT inverse, so you can write that there are 2, so I am writing LT inverse and it is equal to 2 LT inverse. So definitely you will say, sir, this is not valid because the 2 is arising here and the 2 is coming after the adding. Note down the dimensions doesn't depend on the numbers. They depend only on these quantities, these symbols, right? So if there is written 100, 10, 300, doesn't matter, just ignore it and you have to see the dimension of the right side that should be equal to the left side. That means this is the right side and that should be equal to the left side. And just ignore the numbers. Right, so do the practice same for the next equation which I am going to share. So you have to check the validity of the s is equal to ut plus half at square, and you have to check the validity of the third equation of motion called the v square is equal to u square plus 2as. Right, so this is called one of the application of the dimension formula. So you have to do, just I am telling again, don't that means ignore this number if it comes. Okay, right. So what are the steps? Convert the equation into their dimensional formula and ignore the numbers if it comes. So this is called the 1. Now going to the next. The next equation, the application is to find the dimensional formula of any constant. To find the dimensional formula of any variable, yeah, constant, right? So I am writing it as a constant. Okay, so this is, let's suppose we have one equation, right? And you can prepare any of the equation as I am doing, right? This is called the f. Let's suppose the f is force, and I have written this is called the displacement with the work, and this is divided by the power into one constant called the letter, this alpha. Okay, I have taken these type of equations. You can make by your own self. The f is equal to d, where the d is called the displacement, the w work, the p is called the pressure, and alpha we don't know, right? So how you can find the alpha? So you can cross multiply this d w p dot f, convert all physical quantities into their dimensional formula. So I am converting. The d is called the length, so it comes in a bracket L. W has ml square T inverse 2. Okay? And the P is, what is the P's dimensional formula? I also forgot. No. So this is called the pressure is equal to, this is called the pressure or the power. I forgot what I told you. Low is, let's suppose it's the power. Okay. So the power is m L inverse T inverse 2. Work done upon tan is called the power. The ml square and the T inverse 3 will come. Okay. So this is called the power, and the F is ml T inverse 2. Right. So you can cancel the things which are same. So this is called L square, the L cube. This is L square and this is L. So you can cancel all the L's. Cancel, got cancelled. This is M, there are 2 M, so 1 M will cancel. This is T inverse 2 and this is T inverse 2, so it would also be cancelled. What thing got left? It got the M divided by T inverse 3. So if M goes up, then alpha is equal to M inverse. If this T inverse 3 goes up, so it can be the T cube. So this is called its dimension formula. Right? As I know, this is not this kind of dimensional formula we don't know. If suppose there are dimensional formula which comes and which you know, so you can say, so this is quantity is this, right? So this is one of the example. You can do the practice by applying, by taking any of the physical quantity, and you can combine a formula and do the practice same. So I'm going to the next. This is called the application number 2. Okay. To find the dimension formula of other quantity, it is not easy to find by only by this way, right? Suppose as I'm writing here the one equation that's called the PV is equal to an RT, where the P is called the pressure, V is called the volume, N is called the number of the moles, and R is called the Rydberg's constant, and the T is known as the temperature. So if I told you to find the R, so you can do the cross multiplication and easily you can find. But if I told you this is capital P, this is called the van der Waals equation, minus small p into capital B minus small b, where the b is known as the what thing you have to find, and this is called the RT. Say n is the number 1, n is the 1 mole. So how you can find? Now you can find the value, we can say the dimension of the R from this equation, so you can add it here. Okay, then dimension does not going to change. Then how you can find this dimensional formula of the P and the dimensional formula of the V? So it is very simple. If there are two quantities and the equation comes like this, so always keep one thing, you can subtract either the add only one quantity with other. I can add the 5 meter into the 10 meter with the 10 meter. I cannot add the 5 meter distance with the time 10 second, right? So only the same physical quantity can be subtract and can be add. So here this is called the pressure, so it would be pressure. So the dimension formula of the small p always equal to the pressure, and the pressure is force upon area. So this is ml inverse T inverse 2, right? And as I told you, this is volume and this is B. So what should be? The B always is a type of volume, because the volume can subtract only the volume. So the B has dimensional formula L cube. Very simple. See, and one of the example I am also telling to you. Let's suppose this is the example of the 2 only. Another, the question I am writing here. This is called the F plus K, and this is equal to work into, if I write here, divided by the displacement plus the letter O. Okay, so this is one of the equation. As I told you, find the dimension of the K and find the dimension of O. So if F is the displacement, this is called the work, and this is called the S is the displacement. So if this quantity is adding with the F, to K always be force, and if the O is adding with the displacement, then O is our displacement, right? So the dimension formula of the K is equal to the force, and the dimension formula of the O is equal to the displacement. So it is very simple. Let's come the conversion of units from one system to another system. And the third is conversion of unit from one system to other. Okay, so this is called one of the application of dimension formula. As why we are doing this conversation? Because sometimes we know the SI system has, if you are taking the example of length has the unit is a meter, but in a CG system the unit of the length is centimeter. So there should be one comparison between the meter and the centimeter. How much time 1 meter is greater than the centimeter? So the 1 meter is equal to the 100 times than centimeter, right? So this is called the conversation, where the 1 meter is the 1 unit, other one of the unit of the SI, and this 100 then centimeter comes. So the conversion of unit from one system to other system, as I told you, and the simple formula is the N1 U1 is equal to N2 U2. What is the N1 and N2? The N1 N2 is the numbers. Okay, N1 can be the 1 and N2 can be the 10, 100, anything else. And the U1 is the unit of the quantity in one system, and the U2 is the unit of the same quantity in other system. Right? So if you want to find the N2, either if you want to find the N1, so what you can do? You can write here N2 divided by U2 by U1. Either if you want to find the N2, then you can do the N1 is equal to U1 by U2. Okay. So what I am going to do? I am going to find question. Okay. SI unit of force is equal to Newton, right? CGS unit of force is the dyne, right? Convert the Newton into dyne. So this is the question. I mentioned one thing, the unit of force is the Newton in SI and the unit of force in CGS is called the dyne. So now convert the Newton into the dyne. So I can ask the question, how many times the Newton and dyne can relate to each other? So there is one formula. I can say, let's suppose the 1 Newton, and definitely the SI unit is greater than the CGS. So if I write here the 1 Newton, it is equal to, I don't know how many times the dyne is. Then 1 Newton is equal to N dot dyne, and I have to find the N. So what I can do? I can convert the units, these two units into their dimension formula. Okay, let's suppose the dimension formula of the N is सर्दी हो रही है क्या? कोरोना तो नहीं हो जाएगा? क्या पता? So this dimension formula of the N is M L T inverse 2. So this is called the one of the system. So I will write here M1 L1 T1 inverse 2, and the dimension formula of the dyne, it is M2 L2 T2 inverse 2. So what I did, you can see. Now put the dimension formula of the Newton here, put the dimension formula of the dyne here. So I am going to do, okay. So the one and this is M1 L1 T1 inverse 2, which is equal to n times of the dyne, and the dyne has the dimension formula M2 L2 T2 inverse 2. Okay. Now, as I told you, if you want to find the n, then you will write n here, and you will write M1 L1 T1 inverse 2 divided by the M2 L2 T2 inverse 2. So, this n, the unit of mass in the SI unit, in the SI system is kilogram. Unit of length in the SI system is meter, and the unit of time is in SI system second, that is called inverse 2. The unit of mass in the CGS system is gram. The unit of length in the CGS system is centimeter, and the unit of time is same, second inverse 2. So the second inverse 2 got cancelled, and you have to cancel the centimeter and with the meter. Then 1 meter is equal to 100 centimeter. So I will write here, I'm writing here, this n is equal to, and 1 kilogram is equal to 1000 gram, then divided by g into the 1 meter is 100 centimeter, then the centimeter will cancel. So you can write here, and the gram will also cancel. The 1000 into the 100, then how much comes? So I am writing here, this n is equal to 1, 2, 3, 4, 5, 5 zeros are, then 10 to the power 5. So I can write in this equation is here. So 1 Newton is 10 to the power 5 times 10 dyne. So this is called the conversion of the unit. Okay. Right. So this is called one of the examples. Do this and I will move to the next. Okay, so you have to find one more equation, one more relation. So question, I'm giving the question here. Should I write the question? Okay, should I will write the question.